Hello, Dr. Andrassy here, and I'm going to be talking a little bit about reliability as a measure of the quality of the instrumentation that you're using to collect your data. Okay? So, first and foremost, I'd like to again talk about reliability with regard to its relationship to validity. So, whereas validity examines the extent to which the instrument is accurately recording information. Reliability is all about whether or not it yields consistent results. So you can have a test with high reliability but low validity, um, but it's not an ideal set of circumstances, right? Validity is probably more important than reliability, simply because you want to have a situation in which you're actually measuring the thing that you're trying to measure, but it's still important to have high reliability as well, because in order to be useful, an instrument needs to have reasonably high validity and reliability in order to be usable, right? So the way the relationship is often discussed is like having a target and a series of sports weapons to fire at said target. So you can either have a rifle, which is really good at sending a single projectile to one specific place, or you can have a shotgun, which kind of creates a spread of shrapnel that is more likely to cover a larger area, but isn't necessarily going to be as precise as the rifle would be. So if you are trying to put together a good instrument, you want one that is both reliable and valid. You want that rifle in order to place your projectile directly in the middle of the target every time, and consistently put it to the same spot, but also consistently hitting the target as you intend to. Okay. Secondarily, you might want a shotgun pointed at your target, making for a unreliable but still valid instrument. So the shotgun, you're not going to be able to necessarily direct where all of your shrapnel in that case is going to go, but chances are that some of that shrapnel is going to do its purpose and hit the middle of that target, hopefully, right? So that is less useful than, of course, having the rifle shooting at it, but more useful than other instruments, like something that is reliable but invalid, like having the rifle, but you're missing the target entirely, right? That's problematic. You're not getting the job done. You're not doing the thing that you're supposed to be doing. So that's not useful to you. Nor is, of course, having a shotgun that isn't hitting the target as well. You're shooting at the tree next to the target. It's not going to yield the results that you want, which is to get a bullseye on that target. But at the least, the rifle is reliable, and the shotgun is neither reliable nor valid, and is probably the least useful to you. Same thing goes with any type of instrumentation that you use. You want to be precise, and you want to be consistent as much as possible. But if you're going to sacrifice one, sacrifice the reliability. At least get the target that you're trying to hit as much as possible. Okay. So then, let's talk about some of the measures of reliability. So, again, we're talking about consistency. You want the same results across every opportunity that you're collecting your data. You don't want your data to be fundamentally different on one day as opposed to every other day, because there could be something in the way that things are being measured that result in those differences from day to day. Okay, so we're going to start with the concept of inter-observer reliability. It's when you have more than one individual making your measurements, more than one person observing. how you're putting in the independent variable and possibly manipulating the dependent variable if it's an experimental condition. But in terms of just measuring anything, having two or more people observe the same set of results independently, right? Um, and a good example of this is an actual master's thesis that I sat in on. I had uh, a colleague of mine who was, I believe, working with the city of Pomona. It might not have been Pomona, it might have been like one of the surrounding cities, maybe Upland or something like that. But she was in the Parks and Recreation Department. And the city was trying to think of ways to allocate funding for certain parks based on how much they needed them in order to go through, renovations and whatnot to make them more aesthetically pleasing. And so what she did was she sent out her research team to examine the aesthetic appeal of the various parks in the city that she was in. And at first, she would send two people to the same location, and they'd come back with vastly different results, right? And of course, she had lots of different indicators for determining this aesthetically pleasing characteristic. Whether or not the sidewalks had any cracks in them, whether or not the grass was green, or if it was either dirt or burnt out grass, other foliage and things like that on the trees, whether there was any graffiti present. All sorts of different characteristics went into measuring how aesthetically pleasing the particular park was. So what she had to basically do is bring in her testers again and retrain them in order to get the same objective results with what is ultimately a rather subjective sort of measurement. And right, you want to have everybody sort of on the same page and make your subjective measurements as objective as possible if you're wanting to establish inter-observer reliability. And when we move on to understanding statistics and stuff like that, and doing some of the statistical analysis, the way you measure really any type of reliability, such as inter-observer reliability, is you get the measurements of one individual and kind of compare them to the measurements of the other individual using a correlation test. So if it's a numerical standard by which you're rating, for example, the aesthetic appeal of parks, what you would be able to then do is run a Pearson's R test and determine whether there's a strong correlation from 0 to 1 on the extent to which the instrument is reliable. Okay, and the same will kind of go for all these other tests. So the second form of reliability that I want to mention is test-retest reliability. It's when you're trying to contrast different tests at different times, as with a pre-test or a post-test, but really any type of test where you're doing multiple measurements, like a longitudinal study, where you're doing your measurements over and over again at various points in time. You want, for the most part, absent the introduction of some sort of an independent variable or something like that, for the initial test and that secondary test to more or less yield similar results. I mean, not necessarily from a person-to-person perspective, but collectively, you test 50 people, you want there to be more or less the same results the next 50 people that you test that are different from the first 50 people. Okay? And again, you test the initial versus the secondary test, and you can determine whether there's a correlation there as well. Parallel forms reliability is another interesting source of reliability. It's when you have multiple forms of the same test that are different in some way. I'm sure many of you have had professors that give multiple versions of the test that you're taking. There's Form A and Form B, or Form A and B and C, or something along those lines. And usually it's just the order of the questions being different to make sure that people aren't copying off of each other and things like that. But if you are fundamentally changing the actual questions and covering different content, you might get vastly different results from one version of the test to another. And that's not something you want, especially if you are like giving a final exam or you have an easy version of the test, a medium version of the test, and a hard version of the test. That's not necessarily the fairest way to go about getting grades in for students. The students who got the harder test will probably complain that they didn't get the easier test, right? So that's reliability in a nutshell, but then there's another type of reliability I want to kind of focus on, which is the notion of internal consistency as well. Okay, so each of those three forms of reliability are something that you can test with a correlation. The problem is that internal consistency isn't necessarily as easy to test using a straightforward correlational measure like that. So let me kind of explain what internal consistency is, and then how you can go about doing that sort of a test. So basically, the idea behind internal consistency is that the test itself is going to yield similar results at the beginning as it would at the end. So concerns about internal consistency would be that you start off your survey asking one set of questions, and then by the second half or so of the survey, you're asking completely different questions on a completely different topic. You don't necessarily want to do that under most circumstances. I mean, it's not necessarily the worst thing in the world if that is your aim of your study. But, especially if you have longer surveys, people, if you're doing a 300 question survey, which is a lot of questions, people might be giving one set of answers at the 100 question mark and a completely different set of answers at the 300 section mark. And actually, I've taken many surveys in the past that basically ask the same question early on and towards the end to see if there's a difference in the way that the person marks their answers at the beginning of the survey and at the end of the survey. But in general, you have a number of different ways that you can kind of test for internal consistency. The first is split half reliability, where you are doing sort of an even odd split of the instrument, and I guess in that case doing a correlation test to determine how reliable the even questions are to the odd questions. Okay, forget what I said earlier. You can do a split half reliability, and that does do correlation. But you also have the opportunity of doing an alternative to the split half method, which is to use something called Cronbach's alpha. Okay? And basically what Cronbach's alpha does is it looks at all of the possible split half reliability coefficients for all of the different questions in your survey or in your instrument, and it allows you to make those comparisons. I mean, technically it is doing correlation tests, but it's doing a number of different correlation tests and kind of comparing those correlation test figures to one another as well. So again, when we get into statistics, the statistics portion of things, Cronbach's alpha is another thing that we want to kind of look at if we're trying to determine general reliability. And that's kind of what I wanted to go over as far as reliability is concerned. It's just that you want to be as consistent with your measurement as possible. You want to be able to get exactly the type of information that you're seeking to get, and that there aren't various reasons, whether it be the way that you're recording your data, or whether it's the way in which your instrument is set up, that's resulting in vastly different responses from one time period to the next, or from one individual to the next, or that your instrument is not making sense in terms of being able to reliably collect the data about which it's intending to collect that data.